Hello everyone, this is a snapshot video on set operations. Essentially, this will cover material that can be found in sections 2.3 and 2.4. You should be familiar with the following concepts, either from lecture and or by reading. So look these individual concepts over, and then again, you should always try the example prior to watching the video. Stop, try, and play. Problem number 1. We're given two sets as described up above here, A and B. And you're being asked the following questions. Are these true or false? So for A union B, that's what this statement is. A union B, which means simply combine these two items into the same set. So is A union B equal to this? Well, everything in A and everything in B should be contained here. Well, we have 1 in there. We have the 2 in there. We have the 3 in there. The 4 in there. The 5 in there. We have 1 in there, 5 in there, 8 in there, 11 in there. So everything in A and B are contained in this union here. But be careful, because we have to make sure everything here is the same, because this is a true-false question. 11's in B, 2's in A, 3 is in A, 4 is in A, 5 is in A, 8 is in B, 1 is in B. So we have both conditions satisfied. A union B means it's a combination of A and B thrown together. But again, this is a true-false type question, so I had to ask myself, make sure that everything here is in at least one of A or B. Because again, to be in a union, you're in at least one of them. Question B, so this one's true. Are A and B disjoint? Well, disjoint means that they have nothing in common. Well, I'm going to clear this off here. So again, that one's true. A and B are disjoint? Well, they have a 1 in common. It's over with. False. Disjoint means they have nothing in common. D, the number of elements in A and B, that's the intersection, so that's the word and, is 2. So what does A and B look like? A and B, what do they have in common? They have a 1 in common. They don't have a 2, they don't have a 3, they don't have a 4, they have a 5 in common. A 1 and 5 are in common, so yes, this is true. E, B intersect the empty set is empty. What do B and the empty set have in common? They have nothing in common. Why? The empty set's empty. So how can they have anything in common? So this one's true. F, if A intersect B is empty, then both have to be empty sets. So this statement here is saying A and B have nothing in common because the intersection is what do they have in common. That symbol there, what do they have in common? They have nothing in common. Well, that doesn't mean they have to be empty. That does not mean they have to be empty. Okay? Because they could be non-empty, just not have anything in common. So this is false. 2. When would the union of A and B have the same number of elements that A has plus the number that B has? Well, this is what you should be thinking of. The number of elements in A union B is the number of elements in A plus the number of elements in B minus the number of elements in A and B. So for this to equal that, this term here would have to be 0. That would mean A and B have nothing in common. In other words, in order for this to be true, A and B have nothing in common means they are disjoint. That's the key word here. You needed to know the formula for A union B, the number of elements of, and then what do you mean by disjoint? When would the union of two sets be a subset of one of the two sets? See, A union B is a subset of A. If A union B is a subset of A, that means everything in B must be contained in A. In other words, B would have to be a subset of A. Again, the reason why? Because everything here would have to be contained in A. Everything here must be contained in A. Well, everything in B has to be contained in A. We already know A is contained in A, so everything in B must be contained in A. Well, some more true-false type questions. Again, most of the tests are not like this. This is a test to see that you do understand the concepts, okay? So they are a bit challenging. True or false? If B is a subset of A, then A and B is equal to B. Now, if you look at this, A and B is what do they have in common? Well, B is contained in A, so everything in B is contained in A, so A intersect B has to be equal to B. Okay? Everything in B is already in A, so what do A and B have in common? B. So this is true. Is the number of elements in A equal to the number of elements in a universal set minus the number of elements in the complement of A? Now, here's the universe right here, right? The idea of the complement, the universe is split in half. That is not the empty set. And you have A over here, and you have A complement over here, right? Well, if you think about it, here's the universe. Well, the universe consists of everything in A plus everything not in A. So this is true. Another way of looking at this is the universal set is A union A complement. Then you can work with the union counting principle in order to determine this equation here. But both of these are true. Now, suppose A is equal to the set consisting of these four elements, and B is the set consisting of these three elements. You need to determine what A complement is. Remember, that's the notation for A complement. What's not in A? This is a tricky question. You cannot answer. Why? Because you do not know what the universal set is. I gave you B, but I didn't say B was the universal set, which obviously it's not because it has to have everything in it. Since you don't know what is in the universe, you cannot determine A complement. So therefore, this question cannot be answered without knowing the universal set. Number 5. We took a poll of 120 parade goers who saw at least one of the two parades, Rex or Hermes. 75 saw Rex and 55 saw Hermes. How many saw both parades? This is a counting problem. We really only have two counting problems in this particular chapter. One has to do with the number of subsets. I am not choosing things from a set. I am not choosing things that I'm going to put on my sandwich. I'm not choosing cities I'm going to visit. So this is not how many subsets I have. What I'm looking at is 100 parade goers saw at least one of these two parades. I am looking at the number that saw Rex or Hermes, but that's equal to the number that saw Rex plus the number that saw Hermes minus the number that saw Rex and Hermes. This is the other counting problem where we count based upon membership in a set. The number that saw Rex or Hermes is 120. The number that saw Rex, 75. The number that saw Hermes, 55. We don't know how many saw both, so we solve for x, and when we solve for x, we will get x is equal to 10. Think about it. 75 and 55 is 130. Move the x over here, the 120 over here. 130 minus 20 is 10. So the number that saw both is 10. Okay, suppose A, B, and the universal set are defined as above. We need to perform the following set operations for A, B, C, and D. Looking at A, remember, inside parentheses, then you do the complement, then you move from union, intersection, left to right, whichever one comes first, right? So let's look at A. First off, we have to determine A union B. A union B means to just simply combine the two sets together. So I'll throw in A. Then I'm going to throw in B. Well, I already have a 3. I already have the 4. I need the 8 and the 9. Now I need to take the complement of this. So I just combine A and B together into one set. Now the complement is what's not in this set. To determine the complement, I need to look at the look at the universal set. Now, if you look at the universal set, I have the 1, I have the 2, I have the 3, I have the 4, I have the 5. I'm missing the 6, so we know that is in the complement. 7's missing. I have 8, I have 9, I'm missing 10, I'm missing 11, I'm missing 12. So this is the complement of the union of A and B. Part B, I am joining together the complement of A with the complement of B. So the first thing I'm going to do is get the complement of A. What's not in A? I have the 2, the 1, the 2, the 3, the 4, and the 5. I'm missing the 6, the 7, 8, 9, 10, 11, and 12. Then I'm going to join that together with the complement of B. What's missing from B? 1, 2. I got the 3, the 4. I'm missing the 5, 6, and 7. I got the 8 and 9. I'm missing 10, 11, 12. When I join these together, notice I have 1, 2. Trying to put this in order. 1, 2. I don't need a 3. Do I have a 4? I have a 5 and a 6. 7, 8, 9, 10, 11, 12. Okay, so basically this consists of everything but 3 and 4. For C, I want A intersect B complement. So again, before I can take the intersection, I am going to need to determine the complement of B, which I did up here. But I need A. Let's come to write A down. 1, 2, 3, 4, and 5. Now, the complement of B, we already determined, was 1, 2, 5, 6, 7, 10, 11, 12. Now, what do these two sets have in common? They have a 1 in common. They have a 2 in common. They don't have the 3. They don't have the 4. They have the 5 in common. And that's what they have in common. For D, again inside parentheses, what do A and B have in common themselves? A and B have what in common? They don't have a 1 in common. They don't have a 2. They do have a 3 and a 4. They have a 3 and a 4 in common. But I still have to take the complement of this. And the complement of this is everything in the universal set other than 3 and 4. So 1, 2, 5, 6, 7, 8, 9, 10, 11, and 12. So one thing we hope, so whenever we have a problem, we don't have a lot of elements, right? So there is D. So hopefully, again, you can rewind the video and rewatch what I did, but union means combine them into one. Complement means the opposite, what's not there. You look at the universal set. Intersection, what do they have in common? But again, if you think about it, you can't perform an operation until you know what you're operating on. That is, how can I take the complement if I don't know what the union is? How can I take the union here if I don't know the two complements? How can I take the intersection if I don't know the complement of B? How can I take the complement here if I don't know what the intersection is? Now, number 7. Suppose we take a poll. 45 people enjoy crawfishing, 67 like to crab, and 38 like to do both. How many people enjoy at least one of the two? Well, at least one of the two is the union. And we know the union, or the number in the union of people that like to crawfish and crab, crawfish or crab. I'm trying to think of how to write this. Crawfish or crab is the number that like to crawfish plus the number that like to crab minus the number that like both, right? Well, the number that like to crawfish is 45. The number that like to crab is 67. The number like to do both is 38. You do the math and you get is 60. Okay, so again, a counting problem. But again, this is not selecting from a set and how many subsets. It is selecting or actually identifying people belonging to a particular set. So we have people belonging to crawfishing and crabbing, and we're trying to find how many are in at least one of the two. And again, we have that very common formula that we were working with before. Problem number 8. A very recent poll of 170 people found that 65 people heard of Thibodeau, 67 people heard of Morgan City, and 40 heard of both. How many people have never heard of either city? Neither city. Okay, so this is a little bit different, but notice that we know this much. If we have 65 people heard of Thibodeau, and we add to that the 67 that heard of Morgan City, but back out the 40 people that were counted twice because they heard both. Remember, when I said Thibodeau, that did not mean they did not hear of Morgan City. When I say Morgan City, that does not mean they do not know of Thibodeau. So these 40 people heard of both of them. So we double counted. So now I know that this is equal to 65 plus 27, which is now 92. So we know 92 people have heard of at least one of the two cities. There were 170 people there. So those that have never heard of either city is 170 minus 92. So these 92 people heard of at least one of the two cities. We're trying to find out the people that never heard of either city. There were a total of 170 people. So 170 minus 92 is 78. Now, later on, we're going to be looking at Venn diagrams and how Venn diagrams can make this problem a little bit easier possibly to understand and to solve. But I think that is it for the video. So again, thank you.